So before I give the word to our fantastic speakers, just a little bit of logistics. Each of them is going to present for 5 minutes one initiative or activity, their project that they are particularly excited about and that keeps them awake at night. And then we will really open the floor to Q&As for all of you to really engage into what's going to be, I hope, a fun and interactive conversation. So without further ado, I really want to give the word to, we can go in order for me if you want. Our first panelist. Thank you.
Thank you. Hello, everybody. Nice to meet you. It's always a pleasure to be here on a warm Monday morning in July and to be able to exchange with you. First, thank you for joining the summer summer week on data and data science. This is a subject that is key to my heart. It's important that we train and we develop many students in that field. So I'm Stefan. I'm no longer the Operation Chief Digital Officer. I'm the Beauty Tech Program Director. So I'm in charge of a large digital transformation program of L'Oréal. So in L'Oréal, maybe most of you wouldn't expect L'Oréal to be active in AI and machine learning. But we have been for many years now, and I'm going to give you some example of some of the use cases that we are working on. I'm sure you will also cover generative AI, which is a key topic for us when you are in the marketing and creative industry, because we see many things coming our way on that topic, and we are very excited about it. But let's look at what we do with AI. We work on two topics. The first one is to develop services for our consumers, and I will only pick one. Obviously, we develop cosmetic products. To sell cosmetic products that are tailored to each individual, you need to do diagnostic. To do diagnostic, you need to analyze pictures and images of the face of people. And for example, we have developed an acne diagnostic solution that we have developed internally with tens of thousands of pictures labeled by dermatologists that we have used to train some models and to make some recommendations on the type of acne and how severe it is. And this is key because in the world, about 80% of the teenagers suffer acne, 40% of the adults, and most of the people don't get access to dermatologists. So this is a way to use AI solutions to be more inclusive. And that's really at the crossroad of technology, data science and AI, and also science. And it's by combining the two that we were able to develop such solutions. So we have teams internally working on developing all these services that are developed in-house and then spread in our different brands. Obviously, being also a large consumer good industry, we do a lot of use cases on our traditional métier, such as formulation of products. And I can tell you that you can now use algorithms to be able to predict the performance on the formula in silico using algorithms, and yet you don't have to test them in the lab. And when you are a company like L'Oréal, where we are developing 8,000 new products per year, being able to do that using algorithms is helping us to be even faster on innovation. So these are two simple use cases, some examples. So, and on that, what I wanted to say is that we strongly believe at the combination of skills and talents, marketing talents, science talents, and data and AI talents, and that's how we will succeed. And that's what I'm doing, which is transforming L'Oréal into that new company that is leveraging all this talent. So we are working with a lot of people from these different courses, and we will continue to do so. But I'll pass the mic to my neighbor for some more use cases.
Thank you, Stéphane. Good morning, everybody. So my name is Sébastien Gorenek, and I'm working at Total Energies R&D. I'm based here on the Saclay Plateau, so not far from HEC. So it's my pleasure also to be here with you this morning and to kick off this wonderful week. I have seen the program and I think you will enjoy it. So what I'm doing in Total Energies is that I'm leading a team of researchers in machine learning and AI, and we are serving the transformation of the company, which is working and supporting the programs on developing renewable energies and also CO2 capture and storage. And the last aspect of the project is around sustainability. So as Stéphane, I will just give you a brief taste of some use cases we work on. And I will start with solar prospection. So using satellite images, we are trying to give models to our marketing teams and prospection teams using generative AI. Yeah, it's not only about ChatGPT recently, but we are using generative AI to increase the resolution of these images so that we got better details, let's say, on the picture for estimating the shading, estimating 3D attributes, etc. So to predict the energy we will get from solar installation in advance and give tools to our marketing team so that they can call and look for customers. So that's one example around solar prospection. Another example is around wind farms. So we are using, for instance, reinforcement learning to control farms. Usually we control turbines individually in a farm, but there are a lot of interactions, a lot of disturbances between turbines. So it's tricky to have an optimized farm at once. So we are using and developing in-house as well some algorithms to control the farm optimally to give a production which is global. So each turbine can produce less somehow, but when you do the global calculations about the energy production, you will get better production by controlling them differently using RL. And the last example I would like to mention here is a project that is called Safe World. So it's a mix about computer visions and also NLP and text generation. So a lot of sites are building up, like again, solar. When you install solar panels, you're at risk because you are high and mainly when you are on top of buildings. So we are analyzing with AI all the images that are captured by cameras, and we are generating text so that we can describe what we see on the pictures. We can sometimes interpret a bit more than description, and we are building up some models to calculate the risk of what we see on the picture. So this gives a lot of insight and gives some tools to the people so that they can even sometimes stop the chantier so that we can avoid some incidents or some accidents. So it's a nice application of something that is a bit different from energy, but it's around safety, which is the core value of the company as well. Before giving the mic to my colleague, I would like to mention that we are facing some challenges as well, because most of the time our programs are quite complex and driven by physical or chemical processes. And it's not only about cats and dog images. We have much more than that, and it's also multi-criteria optimization. So it's quite tricky, and I think our job is to adapt what we see in the literature, the state of the art, and yeah, we are working with academics as well to adapt what we have in the literature to our problems. And to do that, we have a second challenge that is coming, is that we don't have a lot of data and good quality and label data. This is a common problem in the industry, but we cannot have millions of data. We cannot use CAPTCHA or look for pictures, and so we have to adapt to our problems with a few data, and I think this is one of the main challenges. I can give you more insights and more details if you have any questions. Thank you.
Thanks. Good morning, everyone. So I'm Laurent Nizar. I'm the head of the AI solutions and data science team within Rexel. 20 years ago, I was on your side studying here, and I'm happy to be here today to share my experience on what we do within Rexel. Before deep diving into AI, I'd like to have a few words about Rexel. I'm not sure that every one of you know Rexel very well. We are a B2B company, so not very famous from consumers, I would say. You can remember the figure 20, so we are about a 20 billion euro company. present in 20 countries and with more than 20,000 people, so 25,000 people. Our job is to distribute some electrical products, so all the electrical products that you can imagine. We have more than 1 million products that we sell, so it goes from circuit breakers, lighting, cables, heating, ventilation, air conditioning, everything. We are very linked to the energy transition. Also, obviously, this is the consumption of a lot of electricity. So we are involved in new energies like heat pumps, solar panels, or charging station for electrical vehicles. And our clients goes from a very small electrician installer working on its own to very large companies with thousands of installers. And we work for residential, so it could be for your house, for your apartment, for buildings. It could be for tertiary, commercial, and even for industry. So it's really widespread. And for this, we have an organization of mixing really omni-channel, meaning that we have 2,000 branches, meaning shops, I would say. And obviously, we also have some distribution centers in our supply chain. And we have call centers to take the orders or digital channels that account for about 30% of our sales. So in this context, the AI team is really here first to support all our teams in how data and AI can help them in their day-to-day job. So we are not really here to replace them. We are really here to help them taking the good decisions. So I will give you a few examples. Typically, as I said, we have 2,000 shops. So a branch manager, a shop manager cannot manage all the products that he has in his branch. So what we do is that very regularly we run multiple algorithms to understand which products we should keep and which ones we should add. And this is really a broad view of data science. We don't have only one model making these predictions. So we have obviously some machine learning models to analyze the similarity between shops, to understand which product is working well in which geography. It could be linked to the customer segments that they have, or to the brand preference from one geography to another. So we have machine learning. We have also some statistical models like time series to really understand seasonality. Obviously, when you sell heating or air conditioning, seasonality is very important. But we also have some more usual, I would say, optimization models. We are linked to supply chain, so we are limited in terms of number of products that we can manage or the money that we can have to handle all these products. So we also mix these models with optimization models. So this is the kind of thing that we would do for our internal employees. And we also have some models, as we are also an e-commerce company, that are more towards our direct clients. As I said, we have 1 million products. So one key topic on our web shop is to show the good products very quickly for the user. And this is something very important. Also in the context that our products are very technical, so we cannot sell whatever we want. Our client is really willing to have products that install together within a construction site. And so for this is where we have multiple I would say product recommendation algorithms or search algorithms where AI is helping a lot. We started with, I would say, regular statistical model, then deep learning models like LSTMs that are working well for our use cases, and more now with transformers, where we try to make some A/B tests to see which models are more performing. And for the new area of research, it's also a lot of, we don't really do generative AI, but more using also transformers for data extractions from text documents, where it's quite easy to explain what has been generated by the model to an expert to ensure that what we show is relevant.
Hello, everyone. So it's really my pleasure to be here. I'm Imen El Karoui. I'm Data Intelligence Director at KERING, and I think similar to my neighbor, probably you don't know KERING. because it's the group of Gucci, Saint Laurent, Balenciaga, and now you know what we're working. There will be a big communication campaign around like what is KERING, because no one knows. But basically, so we're the group, and like we have different houses of like luxury fashion, also jewelry with Boucheron, Pomellato, Dodo. These are brands that are probably a bit less known. And so it might be also surprising to have AI and data playing a role in luxury, but actually quite similarly to Rexel, we actually have a lot of challenges to support all the businesses function of the different houses. So this is why our team is here. And so actually one of the main challenge that we have at KERING is the low signal to noise ratio, in the sense that we have lots of clients, but only very few clients who are actually coming back to our store very often. So it means that most of the clients that we have come only once and buy one handbag and then go away. And that's a very big challenge for all of our houses, to basically identify who are the clients who are going to be coming back, because these are the ones that we want to invest in. And typically, so in the luxury industry, you have a very specific relationship to the sales assistant, so basically the person who is in the store. And so I don't know if you're familiar with this kind of store. I was not before joining the company, but basically, like the sales assistant can call you, send you WhatsApp messages. I mean, they know your life and they can invite you to dinner. So, I mean, that's only if you're a very, very good client. Don't. But so identifying the client who have a high potential of becoming a very high client is something that is really key. And for this, so the very top client, they're super well known by the sales assistant. So basically data is not going to play any role there. But we have lots of clients that we don't know very well because they came only once. And so there is a big challenge into identifying who is going to be coming back. And for this, you have like classical machine learning model that works pretty well. We also have a very big stream around supply chain, because so again, in a different setting, we have a low signal to noise ratio challenge here, because as for the clients, most of our products are actually not bought. Because in the luxury industry, and especially in fashion, you have basically only very few bestsellers that are sold many times, but they're basically very small, less than €1,000 black handbag. When like the company wants to showcase like super fancy €3,000 handbags. So basically you have many products that are just there for the image of the company. But it's actually key, because if you don't have this whole brand image, you're not selling the one that you're actually selling. So it's really a bit of a challenge from a data science perspective, because you have to mix this understanding of what is a very good product that is going to be bought by most of the people. So you would like to push this one, but actually you don't want to push this one, because otherwise you're breaking the brand image. And so from a supply chain perspective, we have so lots of products that are sold basically only a few times, but we want to know where we should put this product to ensure both the brand image, but also the potential sales that can happen. And so really identifying the potential bestsellers, knowing where to put them, in which sizes, because obviously like when you're talking about shoes, you have many sizes. So these are really a big challenge, for which we're leveraging on data science, probably more than AI, in the sense that, again, as we have this low signal to noise ratio, we're relying quite a lot on statistical model and also seasonality, because this definitely happens also for clothes and shoes. So a lot of time series models. And also knowing that we have a very high focus on maintenance of all these models. We don't necessarily want to have super fancy algorithms that are hard to maintain. So we would rather go for a simpler, more statistical model that are going to be easy to live with in the next months. So that's basically the two main things. Basically, leveraging on the relationship that we have with the client to identify the one that are like with the most potential, and like also product recommendation. I mean, lots of things around client engagement, and also on supply chain, making sure that we can put the right products at the right place, basically, and producing also the right quantity. So I will pass the mic.
Thanks, Simon. So hello, everyone. My name is Alexandre Cousin. I'm working at VINCI, no more. So from luxury to construction. So VINCI is a big worldwide company working on construction and asset management. So our problematics are a bit different. And our main challenge is how can we spread AI in a group as VINCI, because we are really decentralized group. We have more than 4,400 different companies inside the group. So that's really, really complicated to have the same vision for everyone and to have a kind of a top-down vision about AI. So our main challenge is how can we bring AI on field, and so we reverse the strategy. So meaning that we are more in a bottom-up challenge and bottom-up strategy. So finally, what we do is that we have created inside VINCI a program, AI program, and our job is to detect on the ground what are the good use cases, what are the good business cases we could bring AI with to create more business and be more efficient in our everyday works. So this is our main challenge. Sorry. And so to give you some idea of what we are working on asset management, we have a lot of different issue, a lot of different challenge to go through. And one of them is how can we use AI to do predictive maintenance, because we have a lot of different infrastructure like airport or road or tunnels. And so we use AI, we use data that we have to do predictive maintenance and try to have the best way to help our user through our infrastructure. So this is for asset management, one big topics we are working on. And on the other side, on construction part, there is many use cases that we can work on. And so my everyday job, so I'm head of generative design. So there is, generative AI, we talk about it. And I'm working with structural engineer. So my background is civil engineering. And we try to help the guy working of design of the infrastructure to use AI to produce better solution, some solution that we maybe not have the time to study. And so AI for us, it's a way to be more efficient, more creative, because on some infrastructure or some buildings we are working on, we can use AI to have new proposition, to have new design that we were not thinking about it, or just have new idea. So it's pretty wide, because we are working from pipeline to renovation in the buildings, from bridges and tunnel. So there is a lot of different use cases, like how can we be more efficient in constructing tunnel? How can we be sure that the ground or the floor we are working in will be the good topology and the good quality that we expect? So it's really important to have good model to predict that. And we use AI for a lot of different like for pipeline construction and pipeline industry. The main issue is to find the good way to go. So I have to go from point A to point B, and my idea is to find the best way. So I can choose between very different way. So I have I can go through a mountain, I can go through this place, and my idea will be to test different solution. And so with AI model, we are able to generate 10,000 different ways to go from point A to point B, with environmental impact, with financial impact, with technical impact. And so we mix all the different criteria we have on building and infrastructure in a model to have the best one. So asset management, civil engineering construction, energy model. So AI is now everywhere in our business. And so our strategy is bottom up, finding the good use case on the ground and spread them inside the group.
Thank you. So I'm Claude Lepape. I belong to the artificial intelligence hub of Schneider Electric. So Schneider Electric is a company quite distributed, like VINCI, on industrial automation and energy management. And the artificial intelligence hub was founded about 18 years ago to serve all of our entities, so internal entities having some problems related to human resources, marketing, and so on. And also, of course, our lines of business in industrial automation and energy management. Concretely, in the domain of energy, the things that are important are first safety. Electricity network can be dangerous, and so safety is a very first concern. Reliability, you want to make sure that things are going to work, and in particular, if a particular piece of equipment in the network is aging or is showing signs of potential problems, then you want to detect that as soon as possible to avoid problems. And then, of course, everything related to efficiency. And when we talk about energy, you can measure efficiency in different ways. People are not using energy for fun. They are using energy for doing special tasks. And so for their task, how much energy are they using? So you can measure that in kilowatt hour. You can measure that in terms of cost. And if you look at electricity, the price of electricity is not always the same. And so avoiding the use of energy when it is expensive is, of course, something interesting for our customers. And you can also measure that in terms of environmental impact, so in CO2 equivalent, and try to reduce basically the footprint that you have with your activities. So in terms of AI, that leads basically to 4 types of problems. Some problems of recognition, so recognition that a particular piece of equipment is aging, recognition that a transformer, for example, is much too hot compared to what it has been doing, and so there is potentially a problem. Recognition maybe of what people in a factory are trying to do, and see if they are taking some risk in order to prevent them from taking this risk. Second type of problem, things really related to forecasting. So if you want to better use your energy and optimize for it, you need to forecast how much you're going to need to use. You need to forecast if you have some means of producing energy. So just, for example, solar panels on the roof of the building, you need to forecast how much they are going to produce. You may need to forecast the price in cases where you have a contract that is looking really dynamically on the price of energy. And all of this in order to make the best possible plan in the usage of your energy. And then the third question that often occurs where AI is useful is the management of compromises between multiple criteria. One of my colleagues mentioned multi-criteria optimization. Is it acceptable to reduce, for example, the temperature in the building by so many degrees for so many hours? Or is it not acceptable? And how do you make the compromise between the savings that you can make with respect to that and the inefficiencies that you might have if people are not comfortable? And the last thing that is important is using AI for human-machine interactions. So this starts first with simple chatbots. Now today, with all the generative AI on text, you can do a lot of things. And so, of course, all of these are topics that basically are leading to more efficiency. And so saving in terms of money. And of course, in some cases also getting better information. And once again, if you get better information on energy usage, then this can be the starting point for allowing savings.
Bonjour, my name is Jérémy Arroche, so I'm working at Capgemini. I'm very happy to be part of the panel and very sorry to be a little late. I know all of you directly or indirectly because I've been working for you. I've been trying to work for you for the past 12 years. I'm an entrepreneur, so I developed a company called Quantmetry for 12 years. It's a company, a consulting firm specialized in artificial intelligence with 200 people. And 8 months ago, we joined Capgemini. So now I'm a happy employee at Capgemini, trying to make an industrial project by merging the people from Quantmetry and the people from Capgemini all together in the theme of data science. So it's about 450 people, which makes the biggest human force in data science in Paris. So what is a consulting firm? It's a group of people trying to solve problems for other companies by providing solutions and people who are specialized in this kind of fields to have a better understanding of how to manage and how to handle those problems. So every company here probably has a mix between internal and external people working for them. Why? Because if you just have external, you don't have control and you don't really know if in the next years you will be able to reproduce what you did. But if you have only internal, then you don't have the openness and the capacity to mix talents coming from all over other companies or other fields. So there's always a mix between internal and external, and I'm in charge of the external part because I'm trying to convince these kind of people that by mixing their internal people and my internal people, we can achieve the highest level of quality. So we do a lot of different things at Capgemini, but we do a lot of data science and we need data scientists, but you need to be aware also that there are so many other jobs which are linked to data science, but are not especially speaking data scientist jobs that are super important in the whole process. So we can speak about data analysts, we can speak about data engineers, we can speak about data consultant, and probably there's so many other colors and flavors of data. But you really need to understand we need the whole colors of the rainbow of data to be able to achieve the quality of the process that we are trying to put in charge, in place at our clients. The other thing that you need to know also is the fact that we are trying to be ahead of the technology. So it's always good to understand how the market is moving and what are going to be the new trends and the new technologies and the new algorithm that will pop up out of labs and out of research teams, so that we can always have an opinion on which way is the best way to solve the problems that we will encounter. So what does it mean? It means that at Quantmetry and at Capgemini, we have a lab. So people are working in the R&D and they are providing solutions for people trying to do some research. So how does it work? It's both through partnership with public labs, like the one at HEC or the one at École Polytechnique. It can work through writing research paper and publishing them into international journals. It can work through participating in conferences specialized in data science. It can be by promoting and developing code and algorithm through open code and showing it to the rest of the user so that there's a better understanding of how things will work. At Capgemini, we are organized through expertise, which means that when you start a data science job, you don't work for an industry or you don't work for a process, a function of the industry, work for a type of algorithm. So there are, let's say, 5 or 6 types. You can work for time series, you can work for computer vision, you can work for NLP, natural language processing. There's a huge trend, you may have heard about it for the past few months now, which is called AI Act. So it's a regulatory decision from the European Parliament that will force people using artificial intelligence to have a certain level of certification in the way we use algorithm. So there's also an expertise on that, and maybe other expertise like on generative AI, which is the really hot topic of the past few months. And last thing to be aware is the fact that you can try always to solve a problem, a small problem. You can always try to have a best understanding of a use case. But at the end of the road, what data does in the economical world is there's a huge convergence between physics and digital world. Like every kind of tool that you will use in the next years will be both a physical tool that you have been able to conceive, but will be also a digital tool that you will be able to connect to a digital world. And doing those two things together is quite difficult. And the way we use it is by using data. So data has still a lot of years ahead to be something central in every company. And there are so many ways to use data in the way we conceive, process our products. So you are in the right place to shape the future of the economical world.
Okay, thank you very much to all the panelists. Thank you very much for joining us. Thank you also for being here. The idea is, of course, of this panel and of High Paris that we foster discussions between the industry, which happens to sit on this side, and many bright minds, which happen to sit on this side. And I think one of the advantages of the industry is that you have very interesting problems for us to work on, and very interesting data sets. And of course, there are many new techniques that are coming up and that are developed in the university side, which could be potentially also interesting for you. And of course, this is one of the reasons why we are doing this summer school and also this panel, to bring these two parts together. So what I would like to do now is basically open the floor up to you guys and ask for any questions that you may have. This can be specific questions to one of the panelists or general questions. And ideally, we would get a discussion going between the industry and between all of you participants here in this panel. So are there any questions that you have been keeping you awake at night and that you always wanted to ask L'Oréal, Schneider, or Capgemini, for example?
Hello, good morning. I have a question specific to Iman, because I know actually right now a lot of products, even like all these presenters talked about, like they use AI to get into the production of the products. I know a lot of luxury brands, they also integrate somehow the AI into the R&D and the creation of the products. But I want to know, like, isn't it contradictory to the idea or the brand image of luxury brands always built based on the, for example, craftsmanship and person's human beings know-how? And I don't know, like, what is the limit for the luxury brands, especially in your group, and to just know the limit of like how much percentage of AI or like all these things get into the field that you interact directly with the customers.
So that's a very good question. Actually, I don't know if you realize, but I didn't mention that we use generative AI to like create product. Yeah. But so in KERING, actually, there is a very high focus on like creativity. Like this is the motto of the different brands. And actually, like basically working with creative director is something that we do not do. And potentially could be fun from our point of view, but it's actually like kind of a ivory tower where we do not do anything, exactly because of this, because like for now, the idea of the creative director that are there, it's really that they want to develop the products like kind of on their own. I think in any case, like there has been some like work that are quite innovative at Gucci or Balenciaga, but not on generative AI, but more like around like the metaverse and that kind of thing. Basically, every time it's more like kind of looking at new fields, but always with the creative director kind of controlling what is being done. And I think like everything around generative AI can be things that's open up even new perspective for the creative director. even though it's not done yet. But I think it could be an avenue even for them. But there will still be this very high like human touch in this. And in terms of production of the product, actually at KERING, actually it's based on suppliers. It's not done within the houses, just so you know. And here, so it's really like looking for craftsmanship more than product that are built by a machine. Definitely, I mean, in luxury industry, there is this very big tension between like the brand image and the business that we're kind of living all the time. For example, for product recommendation or that kind of thing, it's really a challenge between what you want to push and the brand image that you don't want to destroy, because really it's what is really important and what you're actually selling. So it's always finding this balance, and it's also what makes it interesting to work in this company, is that you're like providing new tools and new ways of thinking about business problems, but within a framework that is like very focused around the brand image, etc. So you have to think about the problem that you're addressing, taking into account this constraint. It's really optimization and this constraint. And so it's what it also is challenging even for us as a team, like in the AI team, because we always need to take into account all these business aspects, and not just like improving just the conversion. We need to also take into account all this image that is highly important in the luxury, because I mean, in the end, it's really what we're selling. So it's like the most important thing, even more than the actual product.
Maybe just to complement and maybe to give you another perspective, generative AI and creativity. I think generative AI is enabling people to be creative. So it's raising the bar. So it means that the human, us and the creative director needs to be even more creative. So that's the positive aspect of it. And you see already, I was discussing with some high creative people in the media agency, the Publicis and WPP, and they see that part of their tools. They see generative AI as their pencils, their drawing boards, and it's not saying that no, this is AI, this is generative AI. I'm a creative. I'm not using it. It's how can I use that to be even more creative? And I think that's the way, and at least that's the way I see technology, and including generative AI. We shouldn't be, saying no, we don't use it because it will kill creativity. I think it's how to use it to increase the creativity with knowing all the limits, the ethics, the intellectual property topic. But let's see what we can use to be even better. And just to add on another topic, for one creation, if I take the example of an ad, somebody has had the idea, but then you need to localize that in many countries, in many formats, in Instagram format, in TV format, and that job is not very interesting job, but somebody needs to do it, and that's where AI is helping us to do this low added value task. So my take on that is, let's use both of them. Let's not reject the new technology, and see how we can, us as human, be even better and more creative using the technology.
Maybe a follow-up question on this. Do you think like generative AI will also make the creative process faster and cheaper in the end of the day? Any takes on that?
The localization, yes. The demultiplication of the asset that we create, yes. So for us, for example, it's a huge topic on negotiating fees with agencies, because who is doing that is the media agencies. So basically, they will and they are already benefiting from huge productivity levers.
Yeah, just as a complement, and generative AI with respect to creativity is going to help in two ways. First, there are some tasks today that take some time and that can be done faster by using some generation. So that will basically save some time from the creator to really think about the problem. And second, of course, it will enable to explore paths that maybe we would not have explored otherwise. So it may lead to finding some solutions that we wouldn't find naturally. So these two things are going to be useful. And once again, it's going to be highly related with the way between which, you know, the human and what is done by the machine are going to be integrated and worked on.
And just one thing, so definitely it can like improve the productivity on many different tasks. One thing, so it's maybe a bit specific to the luxury industry, but we actually presented to kind of the COMEX members, like what is generative AI, etc. And one of the reaction, we presented an example of Midjourney, like Elon Musk with a luxury jacket, blah, blah, blah. No, luxury outfit. And we saw the image, and he was basically wearing colorful, because it was in the prompt, colorful jacket. And one of the reaction of the guy who is in charge of identifying the new creative director was like, but why is he wearing a jacket? Like now luxury is actually more sportswear. And so there is also this thing of like, based on what the algorithm are trained on, they are like exploring a space that is obviously constrained by what it has been trained on. And so there was this reaction on like, yes, but this is not luxury now. And obviously this is something that only like the top client of our brand would actually identify as not luxury for now. Or like the people who are really into like the fashion industry and the design. It was interesting as a reaction to see that even like if for us, it was really interesting in terms of like exploring the space that is possible. His reaction was to say, okay, but this is not really the space that I would like to explore. So obviously it was just one prompt, and like we could have gone like way further. But it was just interesting to see that as it reflects what's in the past, he was reacting into, okay, this is not really what I would like to see as luxury outfit now.
Yeah, and just to add the last word maybe on the generative AI, generative design. So here in the construction field, we try to use on some infrastructure generative AI, but at the end of the road, it's still the designer who have the hand of the final design. So we still have to work on the definition of the model. We still have to work on the fitness function, the function that will help us to generate the final design. And at the end, it's just a new tool we use, but the skills and the final decisions stay on the designer.
Right. I think there was another question from the audience, or actually two. Do you want to get started?
Hi. Another question for Iman. Iman, you raised a very interesting point, which was about data collection at your end touch points, which are your sales assistants, very important. I am probably one of those one-time end users as well. So I'm curious what's your strategy? What's your company's strategy to make sure that this data collection, creation of this data set is happening? And it's super complicated. And this probably applies to any other businesses and services where your end data point is a person, right? For all salespeople, etc. So one question is around that. What's the data strategy to collect good volume and good quality of data? And second thing, you mentioned something about using simpler statistical models to do what you do at KERING. Just curious why any particular motivation behind that, other than them being easy to manage, because luxury by definition is tailored, it's bespoke, it's for you. So I think there is value in creating more tailored models for smaller segments as well, at least from my perspective, from a third-person perspective. So just curious about that, and thank you.
So about the data collection, so that's definitely a big issue, and I think I'm not the only one facing this. So what we're doing is so lots of training for the sales assistant, and in any case, I mean there is a lot of training because like it's really, I mean, they are really very important in the whole selling ceremony, etc. So in any case, they are trained all the time. To tell the history of the brand. I mean, lots of the different things. And so one thing that is added is collecting the data from the client. Actually, surprisingly for me, actually a lot of clients are actually giving their information in any case, like in the stores. It's really quite different from your usual experience, like for all the people who are not going to luxury store all the time. So actually we do have a pretty good data collection. So what we're doing is also like providing the tools for the sales assistant to have the cleanest data collection possible. So that's the two big things, like having the right tools and also training them to make sure that this is a key thing, and also the like tracking the contactability that we have of all the different clients, so we can identify the touch point where we need to improve. So yeah, these are the two things. And then so about the statistical models that we're using, basically. So really the main challenge is this low signal to noise ratio. So like using very complex models is actually tricky for us because we don't have enough signal. So we have to use our brain to understand better the problems that we're trying to solve, and basically put more human intelligence in the models. And so simpler machine learning models, but more intelligent on our side, because we have to frame the data and prepare the data in a way that is more adapted to actually fitting the models that we have. Typical examples. So as I was saying, we have lots of products that are not sold that much. So we have to aggregate in a meaningful way the lines and I mean, all the products. So we actually have a reasonable time series that is actually something that we can predict. So this, you have to do it like yourself, leveraging on the hierarchy of product that you have in your database. But basically, you have to decide that you're doing this. And it's not like, basically the first version of the models that we had was lots of features, not so well thought, let's be honest, and trying to have basically the signal identified by the models directly. This is not working. So it's really because it's not working that we had to review things to have something simpler in a way, but more well thought before, basically.
Perhaps just to complete on the second part is that indeed with a simpler model, sometimes it could be better, but also it's much easier to maintain. So typically, when you look at Kaggle, you may come with a very complex model and to improve by 0.001, and you are very proud. And as a data scientist, you are happy to put this in production, but actually you increase by a lot the risk of data quality issue or a bug in your program. So the risk for the production is quite important. So this is why we need to be first business focused to be efficient. And also it could be a model that is shorter to train, using less energy, etc. So it's not only the data science performance that we should look at.
Just one last thing about this is basically like, given where we're started from, having like the simpler model that do like 95% of the performance that you want is way more efficient than adding like this 0.1% where you need to put lots of efforts, and in the end it's not so efficient from all the perspectives.
And this links to another important point, which is acceptability of AI, because if you are going from simpler to complex when you develop your models, it's easier to explain to people which are on the field that this works because of this and that. If you can explain it, I think it will be more accepted by the people. And if we take, for example, the example of predictive maintenance, people have been in the field for many years. And if you bring a model which is completely black box, they will not pay attention to it. If you go from simpler to complex, and by chance you have a simple model that works, they will take yeah, they will take this as a tool, and it links to what Stefan was saying. We can use it as a tool so that they decide in the end if they have to go for maintenance in this simple example, or if they can do differently. So acceptability is also linked to the simplicity of the solutions you develop.
Yeah, I think that's a very good keyword, like acceptability. I think there are two aspects to this. So this can be internal acceptability of AI solutions, and that would be basically leading over to my next question to all of you. Like, how can you help AI solutions internally get accepted? Like, how do you convince other departments? How do you convince maybe your CEO to transform also the organization to do these things? That starts basically with collecting data, but then also in the high end. And of course, the other idea of acceptability would be acceptable with the customer. Like, does the customer even know they are subject to AI, or are they, depends also on people analytics, for example, like could also be people working for you, and all those associated issues, for example, if you track employees and things like that. So how do you make, or how can we make AI more acceptable?
I think I partly answered that already. So yeah, so some key points. When developing an AI solution, going from simpler to complex is one thing which is important to me. Also, discussion on the field. I'm thinking more about internal customers and for TotalEnergies. We have assets, we have individual assets, and again, we have to discuss with the people. We have to explain as much as we can how it works, why it works, and why it fails. I think we don't explain enough about failures. When AI fails because of bias, because of data quality, because of anything, we need to be able, as scientists, to explain why it fails and what we can do to overcome this problem. So I think there is a lot of discussions with humans. Again, people on the field, they have a lot of knowledge as well on why there are deviations on process, why the machine is failing, etc. So we need to discuss so that there is this trust that is coming between the AI scientist, I would call it, and the guy who knows his machine for better than anybody. And I think if we can explain and discuss, it will be convincing for most of the people.
Yeah, the adoption of AI, I think for me the main topic is that it has to address a business issue, or it has to address a consumer issue. If it's AI for AI, okay, you can do it, but it won't sustain. So first is make sure that you address a true issue, an issue for the people, and that's will make the solution that you develop using AI sticky, and people will use and come back to it, being the users internally or the consumers. And I think, you know, in the journey of using AI, we went through that. You know, I think it was like 10 to 5 years ago, where we were doing a lot of proof of concept. You know, it was AI was hype. We were doing many topics, and some of them had no value because no usage. So that's the first one. The second one, I think, is thinking about industrialization. It's easy to do, you know, a model on a limited data set for once. You prove that it works. What is really difficult is to industrialize that at the scale of our companies. Industrialization means getting the data flows in a sustainable way, making sure that the data is of good quality. So that's also very important, and not always easy to do that, especially when you scale, you know, in different geographies, in different business type. And I think I will again repeat the transparency versus internal user or external users. You know, for all the models that we develop for our consumers, we are very clear on the type of data that we use, how the model is trained, the scope of the model, where the model is working well, where it's on the edges, and I think that's very important. If you do all of that, you will create some adoption of the different models, and you will generate value.
Yeah, I'd like to rebound on that. So indeed, solving a real problem is the first point. So solving a problem that you wouldn't know how to solve otherwise, or providing a better solution than the solution that already exists. If you have already some way of detecting, I don't know, 50% of defects, and you can come with an AI system that is going to detect 80%, then you're doing much better than what is in place. And so this is really the first thing, is to really solve a problem. Indeed, knowing also how you're going to industrialize and make it in operation, that's the first point. The second point that we see in our domain that is important is aversion to risk. And here there are several difficulties. The first difficulty is that the people with whom you're talking are not necessarily completely at ease with statistics. And so they have trouble understanding when you tell them, well, I'm 95% confident that in 98% of the cases, I will be able to do so and so. Somehow, for some people, this remains very obscure, and they would tend to really react and say, okay, and if you are in the 2% where you're wrong and so on, what occurs? So you need as well to be ready to answer to that, and knowing that you have in front of you maybe somebody who is not completely at ease with statistics, so you need to put it in a way that the people are going to feel is okay. And then, of course, when it comes to topics where a user is going to interact with the system, it's absolutely important that the user knows that it's an AI system that is there, and understand as well that that it cannot be perfect. I mean, everything you do with machine learning, you do learn some things with things that you collected in the past. And the things that you collected in the past, maybe they are not completely corresponding to how things are today. They may have some bias due to history, even if you make a lot of effort to try to reduce that, and so on and so on. And so you need to explain that also to people, and allow the fact that there can be some exception, and you can be in a situation that have never been made before, and that the answer might not correspond to the answer of the past. Just give a simple example. I talked about overheating of transformer. We do some machine learning with data where we use the current that has been going through transformer and the ambient temperature. More and more in the summers that we see today, in some places, there is a peak in temperature that is higher than all the temperature we have in our data. We shall be able to mark that and say, well, here the confidence in the result decreases just because we are not in a situation that is covered by what we have learned from the past. So need to do all that and be clear on all those aspects so that people trust you and understand the limit of the system.
And perhaps to complete, so within Rexel, so the issue that we have is that obviously all our models are, I would say, statistical models. So they are right in 80, 90, 95% of the cases. And as well, we have a lot of experts. We have thousands of salespeople, and they will always pick the cases where the AI is wrong and that it's quite obvious that it's wrong. And this kind of kill the image that you give from AI. But what we see, I mean, our strategy is to help all our employees to raise at a certain level of expertise. They cannot know everything about all our products, and we have quite a lot of turnover. So meaning that some salespeople that goes in and out. So really, from our management, the idea is to say, okay, perhaps we would have 10-20% of the experts who would say, I don't rely on AI because I know everything. But if for all the others we are able to help them take the good decisions, then it's well supported by the top management. And perhaps a last point is also the user experience that is very important. Is that sometimes when you have AI, you may have some separate tools with AI, but then the user experience is quite complex for our employees because they have their mainstream IT systems, and then you come with other AI where they need to go there to have some input from AI. So it's important to integrate really within the IT and within all the processes of the company so that it becomes a standard tool.
And just maybe to complete just on this, actually understanding the standard tools and the standard process are really, really key for the AI team. to actually build solutions that are actually solving something. Fully agree with everything that has been said, but basically, if you don't really understand what is the process and what are the pain points, usually the solution that you provide is a bit off. And so basically what we're doing is really, so working very closely with the business teams. So first we leverage on the expert who spots all the problems all the time, but it's actually also a way to improve and identify where we can do better, or just say, okay, well, this one, we're not going to solve it, but at least we know that it's there. And also it's a way to understand really well the process, and so understand how we fit into this, which is really how we solve it in real life.
Yeah, if I can ask a follow-up question on this, there has been a lot of conversation on like skills and expertise, and even like the different types of jobs that are needed. And I think many people in this audience are interested in entering the industry and potentially like being parts of these conversations in few years. So in your opinion, as you're seeing people entering your teams or applying for jobs in your areas, what are the main strengths or the main area of developments, or actually even just the main like piece of advice or tip that you would give to someone who is building their portfolio to be ready to thrive in this industry? It's really for everyone. So
I believe the right combination. The right combination of skills includes several things. Of course, it includes data science skills. Need people who know how to use statistics, know how to use machine learning, know how to use optimization, are able to engage into making simulations to be able to test solutions and compare, or to provide some additional data from which to learn a model and so on. So these are the technical skills. But then there are things that are really important. I mean, as said, if you come to one of our companies, you're going to work on the problems of the people who are in the lines of business, or of the people who are in the different internal units of the company. And so you will need to be curious about the type of problems they try to solve, about the type of context in which they are, and so on. So being very open and talking to people who have, in fact, the domain knowledge. And it's really the combination of the domain knowledge and of the skills to manipulate the data and do something out of it. That is going to be something that is going to be winning. Also, another thing is that it's a domain where things are evolving a lot. So you need also some skills in both being able to concentrate on the problem you're working on. So the problem you're working on, you can make progress and find a solution. But at the same time, remaining very open about the evolution of the domain, the new techniques that are appearing, and so on. And it's an equilibrium that is difficult to find, and basically need to be engaged with this idea that what you know is very important, but what you don't know yet is also very important.
Concerning skills and talents, I have the feeling that it's very difficult today to have a good understanding of what's going to happen. Past in the years, artificial intelligence was quite of under, let's say, something new, and everything that you have to try was going to be something you could have an opinion in, and you could test in POC and demonstrators and stuff like that. But things has changed a lot. There's so many things that you need to know in artificial intelligence today that it's not possible anymore to ask you students to know everything, all the more than the speed and the frequency at which technologies and algorithms can supersede each other is going faster and faster. So even if you're good at something, you might not be good at this thing for a long period of time, just because technology is going very, very fast. So what we would say is, back in the times, being a good data scientist was about having a very good major and eventually some good minors. Today, being a good data scientist is really being agile and having this ability to change and to understand very rapidly how things are coming out and how you can adapt to all those things. So it's more about learning about how to learn rapidly something new than really learning something special in artificial intelligence. I'm going to give you a few examples. Like generative AI has been in the mood for quite a period of time. We used to call it GANs at some period, and now it's called ChatGPT, but nobody really knows if ChatGPT is going to be the gold standard for a long period of time, or if we're going to have something new in the next year. So the question is more about how to anticipate the fact that something new will happen, and how can you catch this something new at being you the best as this new field of technology, of algorithm that will happen soon. What I think is a right way to not make any mistake is being good at a specialization, but not in terms of technology or algorithm, but more in terms of industry or enterprise functions. So if, for instance, you're very good at supply chain, you want to be very good at supply chain, you want to have a full career in supply chain, invest in every kind of technology that is connected to supply chain at some period of time is the right way to anticipate and to be agile and to adapt to the new technologies. If you just want to be the best as transformers today, you might be overcome someday by something new and won't be able to tackle the next kind of technology that will happen. This is all the more true that now companies are thinking in another way, because AI is such at the center of the thinking of any kind of decision maker and CEO or any kind of company that they have to do activities in artificial intelligence, because they are challenged about that, because sometimes when they are in the market stocks, they have to answer questions about what do you do in artificial intelligence, because the value chain of all of companies are changing a lot. So they have to answer the way that artificial intelligence is a way to protect, to build barriers against newcomers in their industry. And artificial intelligence is the best way for companies to recruit engineers that are at top level, because back in the days when you wanted to have a good engineer, you could take a good engineer in each type of school, in each type of specialty, and you have a good mix. Today, they are mainly using people coming from data science career, academic path, to provide with new engineers in their teams. And what I say about technology and about seizing the new technologies is also true for companies. Technology are changing so many times and so with a high frequency that the only way for us to stay up to date on those is to recruit a lot of new people. So what I would say to conclude is, like, if you know what's the future or if you know what to bet, you're probably wrong. But if you are sufficiently humble to ask yourself and to re-ask yourself how to adapt and how to intelligently understand how the economic path is moving, is the best way to understand the skills to sales and to be a huge engineer and a big talent in those companies.
I have maybe one thing to say. Actually, I come from a background in biology, so not really usual in the field. So I have a PhD in cognitive neuroscience. And actually, I feel like this is helping me a lot because basically the data that I used to look at in the brain is highly noisy, like really noisy. Basically having more data intuition is something that I would love to see more in the people that I'm recruiting. Because people tend to think that the algorithm are working by themselves, and this is actually not the case. And so I tend to repeat to everyone all the time, look at your data. And this is not something that people do very often. And actually coming from noisy biology is actually something that helped me knowing that basically I don't know anything before. And so if I don't look at what is actually the signal that I'm trying to look for, it's better. And so I tend to look a lot at the data, and it's not something that people do usually. And this is extremely helpful. For example, in luxury industry, we have distribution that are so far from normal, then basically you can't do anything with the classical modeling, but you don't realize this until you actually look at the data. So look at your data.
Iman mentioned the beginning of the chain, which is the data, but I think there is a lack also of somehow criticality in the sense that people are not critical enough about the results of their models and the performances. So I think this is also a quality that a data scientist should have. Instead of showing what works and what works well, everybody is usually excited about the good performance of the models and yes, this is great, this is predicting this and that. I always ask the people, can you show me something where it does not work? And then why it does not work? And people should have this kind of distance to their work so that they are able to analyze why it's not working and possibly improve, or again, explain why it doesn't work, because this is a quality that most of the people don't have at the moment. They are really excited about the performance and it's predicting well, but okay, there are plenty of cases where it won't work, and we have to be able to analyze that.
Actually, just one thing to follow up on this. Usually we look at the results when they are not going in the direction that we want to see. But basically, when they go in the same direction as we actually want to see, we should also look at the result and understand where it's not working, and not just confirm our own bias.
Maybe I'll rebound on this as well. There are also some examples where things are globally working, you have good results, but you may wonder, are these the best possible results? And can it be that I could do even better? I'll just give one example I'm quite proud of what the people in the Schneider Electric team have been doing. It's related to microgrid energy management. We have a solution that has been very well engineered, and it's working, and it's saving a lot of money for many of our customers. Yet at some point, we decided to really take the question of saying, can we do it better with other methods? Part of the problem is related to the fact that we cannot make a very precise forecast. So can we do better knowing that these forecasts are not very good? Can we abandon the forecast and do things differently, and so on and so on? And when you start thinking of that, well, first you start using different techniques and you really make a comparison. And second, you can also ask the question, like, if I was really knowing everything from the start, how well would I have done? So if I had perfect forecast, I would have saved, for example, 100,000 euros. Given with my forecast and the way I did it, I saved 60,000. So I'm basically saving 60% of the maximum theoretical. And then you can start, really wondering and say, okay, what can I do to improve and make it better? And then when it's related to things like energy and environmental concern, of course, it's very important. Everything you can win is important for our customers, but for the world in general.
And also, so we already said that what is important is the application for the business. Usually you may have data scientists think something like improving a model, and that's it. And this is quite a lack of creativity. And we discussed about creativity. I think it's also very important to be open on that. And very often business people come with a question, and we try to answer like that. But actually, it's not necessarily the good question. And we need to understand that it was not exactly the good question that we can do on our side, and that there is another need from the business where there is a real answer from AI. And this is what we should work on.
Thank you. I think there's a question from Shirish.
Thank you. So I think the discussion has been very interesting so far. I mean, but it's more on improvement of the efficiency, improvement of reduction of time. One thing probably which occurred to me when I was listening to all of you was about the process in which the decision is made. So often, for example, I mean, we talked about generative AI. often, we have come across instances where, there are instances of plagiarism, for example, in ChatGPT, or there are, data sources that are kind of recombined, from different sources and are presented, So I think it is sometimes becomes very important to know how the solution is being produced. Same is the case in the case of machine learning, which is often a black box. We are not aware of the process in which the decision has been made. So how important is that, for you? Because I know in many knowledge intensive industries, like for example, in medical, when doctors have to adopt, a particular AI system, they want to know what is the process, how the solution has been reached. And often that becomes a bottleneck for the acceptability. That was a question that you were talking about earlier. So how important that is in your industry, and how does it play out, the process of decision making from the recommendation that you get from AI?
I can start if you want. This is a difficult question because indeed, when you learn a model from past data and you learn a complex model, well, it's very difficult to explain it and to really give all the information about it. So first, several elements. The first thing you can do, of course, is introduce knowledge of the physics of the system right from the start. When we talk about overheating of transformer, well, we just know that normally one of the things that is going to have the highest impact on each phase of the transformer is the square of the intensity that is going through this phase of the transformer. So you can directly, right from the start, introduce the square of intensity as one of your main variable and start from there. And of course, once you get afterwards what is happening, you can go back to the square of intensity and say, well, the square of intensity is low, but the temperature is high, which is why we believe there is a problem. So that's the first thing. So choosing the right variables based on the physics of what you know. Second, in some cases, you don't need to make a very big neural network that you don't understand at all what's in there. In some cases, a piecewise linear function is going to be doing the job. And if you have a piecewise linear function, you can then put some tools that are going to look at the function and explain things. When we look at the normal consumption of a building based on the average daily temperature, basically, there are some studies that have been made that show that normally the curve should be quite simple. Either the external temperature is close to 20 degrees, and then you have basically the basics of what is used in a building. I'm assuming some kind of office building where you don't have dependencies on some internal process. So you have basically normally a flat element of the curve. And of course, if it's cold, you're going to have to do some heating of the building and you will consume energy. And the more it's cold, the more you will have. And if it's too warm, you're going to have to do some air conditioning and you're going to have this consumption. So in some cases, you can really say, okay, right from the start, I'm going to try to find a function that has a given shape because normally I should be there. And here again, once you have that, I mean, if you have a curve with just three pieces of a straight line, then it's easy to describe it and to, of course, show it on the diagram. Then, of course, there are some cases where it's more subtle than that, because there are some dependencies that you don't really know. You suspect there is a dependency, but you don't know how much. You don't know how several elements combine together. So indeed, in those cases, you might want to go to a more complex model inside a neural network and so on. And here you must put some effort in order to show, what are the elements that are contributing the most to the decision in the end, in order to provide an explanation that is not going to be perfect. And just as just as the result is not perfect, the explanation is not going to be perfect either. But put some effort in the user interface, being able to show some things. We have, for example, right now one master student from one of the schools of IP Paris working on explainability, and this is something that is going to be more and more important in the future to get adoption and people being comfortable in using the AI system when the model is complex.
Maybe to build on what Claude was saying, one other technique is to give options to the users. not saying this is the choice, but these are the 3 or 4 options, providing some explicability on each of them or the limit, and let the user make the choice. And that's what we've been doing in our lab for digital formulation. We said the model is predicting 4 ways to formulate these new products, and it's up to you to make the choice. And I think that has helped a lot in the adoption and the explicability. And I was thinking of your question, and this has been adopted from by Waze, for example. I don't know if you noticed at the beginning, Waze was only recommending one way to go from A to B, and when I came this morning from Paris to here, I could choose between 4 of them. It was like 41 minutes or 43 minutes or 44 minutes, and I say, okay, why should I pick one or that? But that's exactly this, which is to increase the adoption. At least I'm part of making the decision, and the system is enabling me to do that. So always, as we mentioned, the user interface, the way the system is interacting and giving back the choice to the user will also increase the adoption.
Very much linked to that, I think also one aspect that we give in the industry is like, we mentioned to be aware of the standard process and try to see the added value of an AI models, for instance. You can put both in parallel. So this is what we have been doing in a refinery. We have built up a model that is predicting a failure. And instead of replacing the standard process immediately, saying we have built something that it's much better, and we knew it was much better, we put it in parallel. So people can see how it is now and what the AI stuff is doing for you. And that way you give time for the people. People are not all the same. So one operator can be completely different from another. So people are talking together and saying, okay, this is nice in this situation. And the other way, it's not so nice. So people can see what's the added value that it's giving to them. And that way they, at some point, they say, okay, we can switch to the AI model. So this is another way to do, not to replace immediately what's in place, basically.
Did that answer the question, Shirish? All right, thank you very much. I would like to open the floor again. Are there any other questions on this topic or maybe any other topics? I think 2 hands. I don't know who was first. Yeah, maybe in the back.
Thank you. Yeah, so I had a question regarding the question that Jeremy touched upon, which is that of European AI legislation. And I was wondering what the opinion of the panel is on that question. Is it because it is a specifically European take on the question of AI legislation? I know that a lot of Americans are looking at what Europe is doing. They're not quite at the same level. They're not going at the same speed. And I'm wondering if you guys see European AI legislation as something that might stifle innovation a little bit, or if on the contrary, you're like, okay, we really need this in the field. And this is a very useful and necessary frame in which we're going to keep continuing machine learning based products in a responsible way.
I can start. It's a difficult question. I will use the GDPR topic as an example. So you could, 5 years ago, you could have exactly the same question with GDPR. So what we've seen, at least, is that GDPR has helped to make sure that globally we are making the right thing, and we've seen, GDPR-like regulation being adopted globally. So on that topic, I think it was great, and Europe has led the way on something that makes sense in the use of privacy data. On AI, I think it's I'm mixed because at some stage, when I see what we are doing in the US or what we are doing in China, I think that the pace of innovation is faster. And again, I have to say that in Europe we are lagging behind. I get the questions on the the cloud, the European cloud, how to, and you know, when you take that into account, what is offered versus what we can do elsewhere, that's truly a limitation. So I don't have the answer to your question. It's a topic of a strong interest for us that we are looking at. We are also working with the trying to do our best to help at the European level to influence, so that we find the right balance between privacy, regulation, but not in a way where it would prevent innovation and testing. So more to come. I don't know.
I will make the parallel with the pharmaceutical industry, because I used to work for GlaxoSmithKline a few years back. And I think it was mainly 20 years, a bit more. FDA, so Food and Drug Administration, launched an initiative that they called PAT, Process Analytical Technologies. And this initiative was, in the simple words, forcing the industry to show what they were doing in terms of processes, chemical processes. When they were synthesizing an API, they were saying, us, FDA, we need to know exactly what's happening in your process. The traditional way is it's a batch process. So you have a stage of the synthesis, and you go to a quality control lab and you show the results, and it's fine. At that time, the FDA launched this initiative to say, any time of the process, we need to see what's happening. And I think if we make the parallel with the AI Act, it could be nice. In some way, I agree with Stéphane, it could not prevent from innovation, but we also need to have some gates of some milestones, or some key aspect that should be auditable at any time, that should be respected, and we should agree, whether it's US or Europe, we'll see. But we should be able to show some key aspect about data, about the way the models are designed, obviously the way the models are validated, because we didn't touch this point, but validating a model is key, absolutely key, and I think there's not a lot of effort on that. So we should have some elements that are some standards and common to any of us. So yeah, and again, if I keep the parallel with the pharmaceutical industry, there is the FDA, but there is also a European agency, and there is even a French agency, and somehow it's like, I don't know how to say in English, but poupée gigogne. So what's in the country could be legislated by Europe and the FDA ultimately. So we could, it will come, and we need to have that to my opinion.
Yeah, I mean, mixed emotions as well. First, I mean, there are some areas in which using AI induces some risk, and so having regulation to ensure people are serious about it and contemplating the risk and reducing the risk is of course something good. And so basically two things: risk, which can be a risk about the safety. You make a mistake in some system, and something now is on fire and kills people and so on. And risk also in terms of being fair between different people, having, I don't know, a CV sorting algorithm that is really bad. I mean, it's really something that is a catastrophe and should be avoided. So on the principle, on having a regulation in order to make sure that people who are doing critical application respect some ways of doing it that reduce risk, I mean, it's of course something good. Part of what is good with the AI Act is that they have adopted some risk-based approach. They define 4 types of categories, things where there is basically no risk. Minimal risk, you need to let people know that they use an AI system, and then high risk, and here you need to be serious. And of course, the things that are globally forbidden, so that this is good as well. Then after comes the complexity that comes with that, and this is where we should be very cautious. Each time in front of a risk, there is an effort to reduce the risk, and you need the effort to be in good proportion to the risk you want to go for. And so this is, of course, something we are following very carefully. Together with the Act, there are going to be some standards. So what we expect is that the standards are going to be reasonable. When I say reasonable, rational, if you want, and that basically the effort that people will have to put to cover the risk are going to be in good proportion to the risk you want to cover, and in which case it will be good.
Thank you. I think we have time for one more question. I think he was first. Maybe we have time for 2 questions.
Yeah, I had a question just to understand the process, because the data for all of the companies are very important and probably confidential as well. I'm not sure about it. So just a question, how important is this data? How confidential it is? And when you run all this algorithm and everything, is this all in-house still within the company? And the question also probably for Jeremy, where he was saying external, are the companies comfortable to give this data outside and let other people run this statistic? I just wanted to understand the process. How does it work?
Yeah, I can start with that one. When we look, for example, at energy data, that's something very, very interesting because you can see different cases. I mean, you look at the energy of an office building, while it does not tell you big secrets about what is done in the building. And so basically, our customers would feel quite comfortable that we have access to this data. If we take now the energy consumption of, for example, a steel factory, then there is a clear relationship between the consumption of energy and what is being done in terms of production and so on. And so here you start being in an area where our customers would like to make sure the thing is secret. In some cases, they will not even give us access and they would ask our solution to be running on their premises just for that reason, just to make sure the information doesn't go away. Then you have another third case, which is the residential case. We are talking about the energy in a house. And here, if you have too much detail, it gives you some information basically on what's happening in the house. And so which is not good in terms of privacy. And so this is yet another question that needs to be solved. Either people feel that what they're going to gain is worthwhile and they're confident that, of course, the information will not go away everywhere. Or some people are likely to say, no, I don't want this information to go. And so I want a system that works on my premises and the information is not going to be communicated. It's the same thing if you look at an electric car. We are working on a number of topics related to better managing the electric consumption of electrical vehicle charging. In some cases, we have some ideas where we would like to really identify the car. But then if we start doing that, we go in a thing where we have a car and we have a lot of information on the usage of the car. And at some point it becomes not acceptable and you cannot do it. So very different cases can arise. And of course, it has an impact on where the data is going to be, how much the data coming from different places can be merged together. You can learn, for example, from 100 different buildings, you can learn a model, but in the case where each customer doesn't want to give its data, you cannot get the data of 100 sites and learn something from it. So all of this has an impact and you need to develop the right solution depending on the constraints that you have.
Just to add, I would say traditionally we are quite conservative, so we don't share the data. I don't know if I can speak for all industry, but at least in Total Energy. What we see is that we are trying to push for sharing the data, and it opens a field of research, by the way, which I can put here in the room, is like how to share the data without compromising the right information. So we can use federated learning or other techniques. But this is a field of research that is very interesting to us because we'd be happy to share as soon as we protect somehow some contents. And I think other industrial partners would be in the same situation. So academia is looking for industrial data sets for sure. They want to have right data for complex problems, as we said during this roundtable. But it's not always easy because when it's strategic or competitive or when it touches privacy, we cannot do it. So yeah, there are many ways to do things better. We are trying to push for it. Sorry, but well, it's not there yet.
Yeah, I mean, just to add on that, that is also limiting the progress of yourself, let's say, as a company, right? If you cannot run much advanced statistical analysis, which external companies are able to offer, maybe, and probably it makes you slow down. Do you take it in that way, or?
Yeah, it's slowing down somehow. Yes, that's for sure. But we have, for instance, a PhD on batteries, because batteries is a competitive activity of Total Energies, and there are some data sets that we can see on some publications from the NASA, for instance, stuff. But we are looking at a way mathematically to merge different data sets. It's not always easy, not always obvious, but this is the way we see things as well. Can we share the data, and can we merge the data together, which are somehow a bit different? And yeah, this should be able to accelerate the research, and yeah, the opposite is slowing down. Yeah.
Just to give an additional word concerning sharing data. So companies are very secretive. They don't share any data. It's very, very rare. The only move that I've seen is the switch from like platform Hadoop, which are local, to cloud computing, which is a sort of sharing, even if we think that Microsoft, Google, and Amazon don't look at the data. It's a change of my mindset, which was huge, because at the very beginning, people were saying, never we will go on the cloud. And now I think that cloud is a sort of gold standard, and nobody think about starting a project, maybe in defense, where you have a high level of secret. On the other hand, the economics behind sharing data is tremendous. We've observed that when we make a partnership between a retailer and a provider, and they share data, the volume of the use case and the volume of value creation is like very, very big compared to each entity. But the problem of that is decision makers, like CEOs of those companies, they don't have a good reason to make this decision, because if they're right, they will make a few points of performance. But if they're wrong, and if there's a leakage, they will lose their job. So nobody wants to make this kind of decision. The solution for that links to the previous question is regulation. Like if we are able, the same way we do for the AI Act, to build a framework in which we are able to assess the risk and ask for the proportionality of the reporting of the efforts to reduce the risk. If we can do that for sharing data, then there's a huge size and deep of economics and of value creation that can be built, because there's so many data and so many crossing of data that you can do, that it will be a new wave in the data industry. I'm asking for this kind of regulation, but I have a feeling that things are going very, very slow. So I don't know where we will see it. But if Europe wants to be a place where they are able to finance the new industry of sharing data, I think Europe is the right place, because Europe is known to be good at regulatory and good at concentrating data. So maybe there's a place for the next 10 years to have Europe being a top player in the data industry, which is, to be honest, not really the case today, but hopefully we will be one day at the top of the world.
All right, thank you very much. I think for this interesting discussion, I think we could go on forever. I like the closing words, to be at the top of the world. I think that's a good mission where we would like to get, and maybe we could contribute to this goal a little bit with this discussion. There's also more time afterwards during the coffee break. I think most of our panelists will stay around. So if there are any specific questions you would like to discuss, please do so during the coffee break. I think we covered a lot of ground. We could do much more, but this is also good because we will be doing a summer school again next year. So thank you very much for coming, and also to you for joining us. And I hope you have a great week. You learn a lot, and I hope to see you around during the next 3 days. Thank you very much.